What I want to do, just for additional practice, now you might say, Dr. Darbo, I don't need any practice. I'm not going to believe you. But anyway, just for extra practice, let me get this a little bit clearer. It's going to bug me. Just for extra practice, going to take a look at these. So first question, insurance claim is reviewing its current policy rates and has been led to believe that the average claim amount is $1,800. They are concerned that the average claim amount is actually higher. The company randomly selects 40 claims, calculates a sample mean of 1960 and a sample standard deviation of 500 respectively. I don't know why that's there. At .05 test if the insurance company should be concerned about rising claims. Well, guys, you need some structure here, and the structure comes in the four-prong approach. First thing, we need to state the null and alternative hypothesis. So in this case, that's what the status quo is. What's currently believed is the mean is $1,800. Remember, H sub A is going to be the same notation, the same number, and then you dive into the problem to see which inequality, and I think it's really clear that we're going to use greater than here. Because we want to see is they're concerned that the average claim amount is higher, so we test greater than. The second thing is we kind of prepare for the test. First thing I see is that the alpha level is .05. Next thing I need is random. So I've got that. And independence is one of those things that you just you assume to be true unless there's red flags. Independence is typically, when you see the word random, that typically checks the independence box as well. Guys, the third step is we got to decide how we want to do this problem. Do we want to do it the p-value approach or the critical value approach? This one's easy. This one's hard. This one's not easy. I don't know about you, but when I got the choice between doing something the easy way versus the hard way, I'm going to choose this every single time. So when I do that, I need to calculate two things for the p-value. I need to calculate the test statistic, which in this case is the t-value, and I need to calculate the p-value. Well, guys, I'm going to use technology. So I am going to go to StatCrunch. I am going to go to Stat, T-Stat, one sample. Because I don't have my data here, I've got my summary. So I have to go with summary. So my sample mean, it looks like, was 1960. The sample standard deviation was 500. And the sample size was 40. Right? Yeah. Now I want mu equal to what's currently believed is that the rate is 1800, but they are concerned that it is raising. All right, hit compute. You can see that our test statistic is 2.02, and our p-value is 0.0249. All right, so I wrote that down over here. The fourth thing we do is we make our decision. And remember, we compare the p-value with our alpha. So our p-value we got from StatCrunch, 0.0249. Our alpha was set before we started the problem. So we can see that our p-value is less than our alpha, which leads us to reject H sub O. All right? So when we reject H sub O, we are essentially drawing a line through the null hypothesis in saying that the alternative hypothesis is more believable. Now remember what, in the very first video that I put up, I said hypothesis testing enables us to make a decision between two statements. Statement 1, Statement 2. Based on this criteria, where our p-value is less than alpha, the alternative hypothesis that the mean has actually increased, it's higher than 1800, is more believable than it hasn't changed. Okay? So at alpha equal 0.05, there is sufficient evidence to indicate that the mean insurance claim is not $1,800. And we could actually conclude further that it appears to be higher than $1,800. Light bulbs. A light bulb manufacturing company makes a claim in an advertisement that their light bulbs last 500 hours on average. You suspect their claim, and would like to test it. You randomly select 35 light bulbs, which have a sample mean of 496 hours and a sample standard deviation of 10 hours. Carry out an appropriate test of hypothesis using a significance level of 0.10. Now again, start with the null hypothesis. H sub O in this case, status quo is the company claims 500. We suspect it. Now, it doesn't say we suspect it because we think the bulbs are actually better than what they've advertised. It doesn't say we suspect it because we think the bulbs are not as good as what they've advertised. It doesn't know. We might think they're better. We might think they're worse. It doesn't say that. It says we suspect their claim and would like to test it. So that generic vocabulary, that generic way of stating the intent of the test is not equal to. Secondly, our alpha level changes this time. It's 0.10. Randomly selects. So that right there takes care of the random and independence. And I don't think I talked about this in the previous. N needs to be greater than or equal to 25. And we have 35 bulbs, so we're taken care of there. So again, p-value approach versus the critical value approach. I'm going to work this one using the critical value approach. I don't know why, because if I was doing this problem myself, I would use the p-value approach. But I just want to demonstrate the critical value approach, and then I'm going to work it with the p-value approach. Critical value approach says what? Distribution of sample means. Two-tailed test. Find the left bound, find the right bound. Okay? So we have degrees of freedom equal to 1 minus the sample size. So we have 35 bulbs. So degrees of freedom 34. We have alpha 1.10, so the sum of these two areas has to be 0.10. So that tells me that this is 0.05 and this is 0.05. So guys, with StatCrunch, this is pretty easy, right? Stat, calculator, T. We have a degrees of freedom were 34. I'm going to take a little different approach here. I can do between. And I know that if I have 5% of my left tail and 5% of my right tail, that between these two values, I have to have what? 0.90. Compute. Negative 1.69. to positive 1.69. All right, let's get some descriptives, because what do we need to do? We need to calculate our test statistic. That's x bar minus mu over our standard error. So let's go get that information. We know that the value goes for mu is going to be this up here, 500. So we have to use StatCrunch to get the descriptives, the sample mean and the standard error. It's going to be easy though. Well, you know what? What am I thinking about? I've lost my mind. The sample mean is given in the problem. It's 496. And the standard error is the standard deviation, 10, divided by the square root of the sample size, which is 35. I'm going to put parentheses around this so we don't get wacky with any order of operations. So grab a calculator. So 496 minus 500 divided by 10 divided by the square root of 35. So I get negative 2.37. And I can come all the way around here, and looking at my drawing, I can see the negative 2.37 will be to the left of negative 1.69. So this falls in my reject region. So decision, reject H sub O. It's more believable the mean is not 500, and since our sample mean is below 500, it seems to me, based on this study, that the light bulb company is deceiving us, and their light bulbs aren't lasting as long as what they claim. Now, what would be really cool is to perform a confidence interval to see exactly where this lies. So I can do that. Go to t-stat, one sample with summary. Sample mean is 496. Sample standard deviation is 10. Sample size was 35. Come down to confidence interval. We had a significance level of 0.10, so we want a significance confidence interval of 0.9. I explained that in a previous video. So I'm 493.14 up to 498.86. So it's much more believable that their light bulbs last somewhere between 493 hours and 490, almost 99 hours, not including the 500 that they claim. Now, how would that have changed if we had used the p-value approach? P-value approach is really simple. We just calculate the p-value. So I'm going to go to stat, t-stat, one sample with summary. A sample mean was 496. The sample standard deviation was 10. The sample size was 35. I want to test 500. And I want to test not equal to 500. Compute. You can see the p-value is 0.0238. Which is less than our alpha of 0.10, which, I'm glad to say, leads us to the same decision. Now, what's the difference? Well, the difference in the final outcome is nothing. You reject whether you use the critical value approach or the p-value approach. The difference is this one, once you get good at it, you can do it in about 15, 20 seconds, where this one takes more work. This one is going to take you 3, 4, 5, maybe even 10 minutes. So, guys, when you got the option, do the p-value. All right. So, guys, there's only one more video I'm going to put up on this. I'm going to work a couple of problems off of my stat lab. So, guys, after that, we'll be done with hypothesis testing for means. So, take care.